Hello, my name is Giovanna Vasquez, and my work is synthesis and optical characterization of substituted metallophthalocyanines and semiconductor behavior. Well, in the introduction, the general structure of metallophthalocyanines is there, and in the center of the organic molecular is the metal. In this structure are different P conjugations bonds, and these characteristics of the metallophthalocyanines have different properties and interesting properties for the semiconductor behavior. Metallophthalocyanines have attracted considerable attention because of their unique optical and electronic properties, together with their high chemical and thermal stability. They are organic semiconductor molecules with numerous applications, such as organic solar cells, chemical sensor and electronic devices, and optical data storage. The relevance of PCs and their analogs result their variety, architectural flexibility, and exceptional environmental stability. The phthalocyanine molecular have a two-dimensional p-electron conjugated system, and a number of modifications can be made either and macrocycle by incorporating more than 70 different metal atoms or by inserting side groups at the peripheral sites of the macrocycle. These chains facilitate the tailoring of electrophysical parameters of metallophthalocyanines over a broad range and consequently allow modulating the electrical and optical behavior compounds. In this work, the synthesis and characterization of new organic compounds, 1-paraminophenyl 2,5-diphenyl-pyrrole was carried out through a reaction of dissonant salts, functionalizing the phthalocyanine molecules with different metal centers, zinc, copper, and cobaltum. The characterization techniques used were Fourier transform infrared spectroscopy, proton, nuclear magnetic resonance, and thermogravimetric analysis. Subsequently, studies of the optical properties of the new materials obtained will be carried out. Okay, in this case, the different stage of synthesis of the different precursors of the phthalocyanines is the Glaser-Hay reaction and Reich-Schulter reaction with obtained compound 1 and 2. Subsequently, the reduction of nitro to amine compound and the reaction to deazoning salts obtained the, in this case, the metallophthalocyanine derivative. The synthesis of the metallophthalocyanine, in this case, is the functionalization for the diazonium salt in this molecule. Obtain the different compounds of different metals with different colors. And subsequently, the different characterization of the phthyl. In these positions are the different functional groups of the pyrrole and the phthalocyanine. In this case, the substituted metallophthalocyanine. The air magnetic resonance proton are indicated in 8 and 9 ppm. The signal characteristic of the phthalocyanina, and in the 6 ppm, the signal characteristic of the pyrrole derivative. For the terminal analysis, in this case, the melting point of the different metallophthalocyanines is the 202 centigrades, and subsequently the different studies of the diffuse reflectances was possible to calculate the EG, band gap energy in the electron volts, is the 1.7 electron volts for these compounds. And in this form, the synthesis and the ammonium salts method have been applied successfully to functionalize metallophthalocyanines molecule with 2,5-D substitute pyrrole. It is necessary to time the theoric DFT study, and the next stage is to elaborate the dim film and characterize the electrical properties to determine the possible application of this compound. Thank you very much.